An SwRI-led consortium is tackling the challenge of decarbonizing the transportation industry, and they have just unveiled a new heavy-duty vehicle with an internal combustion engine that runs on hydrogen. Is this zero greenhouse gas engine ready for the road? That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform. Hello and welcome to Technology Today. I'm Lisa Pena. Zero carbon fuel, ultra low emissions. That's the mission of SwRI's Hydrogen Internal Combustion Engine, or H2-ICE Consortium, a group of organizations working together to decarbonize transportation. The consortium has designed a heavy-duty vehicle with a hydrogen engine that is reducing tailpipe carbon dioxide emissions by over 99%, and it's picking up a lot of interest and attention right now. SwRI engineer Ryan Williams, consortium program manager, is part of the development team rolling out this clean energy engine. He's here to tell us more about this decarbonization alternative to battery electric and fuel cell vehicles. Thank you for being here, Ryan.
Thanks for having me. I'm happy to be here and happy to talk about this program and the technology.
Okay, so let's start with an overview of hydrogen as a fuel. What are the benefits of hydrogen?
So the real benefit of hydrogen is in the absence of carbon. Like you mentioned in the intro, we're trying to decarbonize transportation and much of industry in general. There's a general realization for the need to reduce our greenhouse gas emissions because of the effects that we're seeing in global warming. And we still need energy, we still need fuels, we still need trucks and transportation to be able to get around and do all the things that we need to do. And so we need to find energy carriers that allow us to do that without producing CO2. And so hydrogen is one attractive fuel because it's still, similar as an energy carrier to traditional fuels that we're used to using, but it just doesn't have the carbon there to emit CO2.
All right, and that CO2 is harmful to our environment, causes pollutants. So to explore the benefits of hydrogen, SwRI launched the Hydrogen Internal Combustion Engine, or H2-ICE Consortium, in November 2022 to demonstrate the potential of H2-ICE vehicles. So tell us about the consortium and how it's advancing the hydrogen engine.
Yeah, so this consortium is really targeted at demonstrating the benefits of H2-ICE as maybe an alternative. So right now, the predominantly accepted technologies in this decarbonization space are battery electric vehicles and fuel cell electric vehicles. And outside of that, we don't have too many alternatives. So if you've got an application that is difficult to use a battery or a fuel cell, then you're kind of out of luck. And so the H2-ICE is more similar to traditional combustion engine, similar to like a gasoline or a diesel or a natural gas engine. And so we've formed this consortium to be able to bring that technology forward as an alternative and demonstrate it to both the industry and to the regulators across the transportation industry to see the potential of hydrogen, another use of hydrogen in this space.
Okay, so you get this consortium together, this group of organizations with this similar goal, wanting to see this H2-ICE engine come to fruition. So what are the steps here? How do you design and develop this new technology?
So like anything else, we started with existing technology. Our goal here wasn't to completely redesign the engine from scratch. Our goal was to say, look, we've got existing technologies here that can be adapted to run with hydrogen, so that we still have we can build on all of the progress that we've made over the last several decades, but then apply that to hydrogen to eliminate the CO2 and the other emissions that are harmful from the existing technologies.
So what are those meetings like, those first meetings where you're like, let's try this, or did you have an idea that maybe these existing technologies would accommodate hydrogen as a fuel, or was it a little trial and error, maybe some of both?
A little bit of both. So the way that it worked out, we had done some of our own internal research to look at hydrogen. I managed the Spark Ignited research and development team within our division, and so we already had some ideas about how to burn hydrogen and how it's going to function in an engine. But then we came together with all these consortium members, and each of them would say, I've got this technology that I can add, or I've got these parts. And so it became this very collaborative effort for everybody to kind of bring what they had to the table, and then we integrated all that together to build the vehicle.
All right, so you're building this vehicle, and you started with a heavy-duty Class 8 engine. So why start with the heavy-duty engine and not, like, let's say, a smaller passenger vehicle engine?
Yeah, that's a great question. The reason we started with the heavy-duty vehicle is because, like I mentioned before, there are some applications that are just going to be hard to decarbonize. Battery or our traditional passenger cars are smaller and lighter weight, and so it's maybe easier to get a battery into a car and make it run on electricity. But the problem is, once you try to scale that up to the size of a Class 8 truck, the batteries get very large and very expensive and very heavy. So you can add about 20,000 pounds to your vehicle before you add the payload. And so with trucking and transportation in general, it'll be very difficult to apply that solution all the way across the industry. And so we're looking for alternatives, particularly in that heavy-duty space, because it's so energy intensive. We need alternatives to batteries in that space.
So is the thought that if you tackle the big vehicles first, maybe some of that technology could trickle down to the smaller vehicles easier?
No, our thought is really that it's going to take a little bit of everything to decarbonize transportation. There's no one silver bullet that is going to be the perfect solution for every application. And so we need to develop these technologies and then see where they fit, rather than the approach that's been taken in a lot of the world is to mandate the technologies and make it fit into every application. What we're trying to do with this is develop the technology and then explore the space and see where it fits.
So great place to start. So let's discuss the vehicle's after-treatment system. In a traditional combustion engine, the after-treatment system reduces harmful pollutants before they escape into the air. So with already zero greenhouse gas emissions, why does the H2-ICE engine need an after-treatment system?
So with combustion, we make CO2. Generally, if you've got a hydrocarbon fuel, you've got hydrogen and you've got carbon in the fuel. You burn those and you end up with CO2 and water in a perfect world. The reality is we've got other things in our air. So there's a lot of nitrogen in our air. And so when we combust that, we get trace amounts of nitrogen oxides as well. And those are harmful to human health. They cause things like smog and acid rain. And so we need to reduce those as much as possible as well. And so that's what we're doing with the after-treatment system on the vehicle is we've already reduced the carbon just from eliminating it from the fuel, but we still have to get these other emissions as close to zero as possible.
Here's a topic that comes up when you talk about hydrogen and putting hydrogen fuel in a vehicle. So how safe is an H2-ICE vehicle during an accident compared to a traditional vehicle? People think hydrogen, and for many, the Hindenburg disaster of 1937 comes to mind. And that explosion killed 35. That was a hydrogen-powered airship and a spark-ignited leaking hydrogen causing that explosion. So what type of safety measures are taken around hydrogen engines, and how do you get around the association of hydrogen with that disaster?
Yeah, that's a good question that we get all the time when we talk about hydrogen and combustion together. And the interesting thing to note is that in the Hindenburg, with that fire, it wasn't actually the hydrogen that was doing most of the combustion. It was actually the skin of the vehicle that was burning. With hydrogen, if you develop a leak, it's so light and so diffusive that really your hydrogen disperses very rapidly, and so you don't have a combustible mixture that hangs around that can cause an explosion. So there's not as much concern from a safety standpoint about combustion around hydrogen. The bigger concerns are about the high pressure that the gas is stored under, and making sure that's safe. And the good news is that we've been looking at hydrogen. So you may remember back in probably 2003, early 2000s, there was another big push for hydrogen vehicles. And so we started developing the safety regulations around hydrogen storage and those high pressure containers. And there's actually a lot of work that we do here at the Institute looking at combustion or high pressure vessels and their integrity and how they hold up in accidents and things like that. And so there's a lot of regulation and a lot of standards already in place in that space. And so while we're introducing a new way to use the hydrogen with the internal combustion engine, there's already a lot of existing safety standards around the storage and the carrying of hydrogen on a vehicle.
All right, so checks the box for safety, another benefit of hydrogen. So how do maintenance costs for an H2-ICE vehicle compare to traditional vehicles? Is it more expensive to fix it?
In general, we would expect them to be about the same. So, of course, there aren't a whole bunch of hydrogen vehicles out there, so we don't fully understand the long-term durability and things like that. But because so much of the technology carries over from traditional internal combustion engines, we expect that maintenance and just general parts and things like that should be very similar to current vehicles.
All right. Is the H2-ICE vehicle ready for the road? Are there any technology gaps that your team is addressing?
So I would say, like I said, for this demonstration, we took what was available and we integrated it into a vehicle to show viability for hydrogen. But the vehicle that we've built is, I would say, acceptable for the transportation industry, but it is by no means ideal. There's certainly some optimization. We'd like to be able to get more power. We still have some concerns about within spark-ignited engines in particular, there's a phenomenon called knocking and pre-ignition where the combustion chamber can get hot enough that your fuel burns before you want it to. And so that leads to problems with the engine. And so there's still some of those things that need to be worked out. We've identified those, and we're actually rolling those into our more research-focused consortium, which is our HEDI consortium that stands for Clean, Highly Efficient, Decarbonized Engines. So we'll continue to look kind of to the future of how can we increase power density on these engines, how can we reduce this occurrence of knocking and pre-ignition. And that's all things that we'll be looking to do in future consortia.
So if you could put a number of years on it, how soon do you think we'd see some of these H2-ICE vehicles on the road?
So we've already actually done some testing. We've got some partners who are field testing hydrogen engines. So we had a few Institute personnel that were on site to witness a field demonstration of a hydrogen excavator. earlier this year. And other OEMs have made announcements. So probably the earliest we expect to see hydrogen engines coming into production is about 2027. And then it's really probably around 2029 timeframe that we would expect more widespread adoption of H2-ICE.
So you're just kind of in the tying up the loose ends phase.
I would say we're in the phase of the early adopters. So like I said, we can get a hydrogen engine on the road today, but it's not going to have the same efficiency and power density and all of the refined technology that we have on, say, a diesel engine today. But if somebody wanted to get a hydrogen engine out there, if they want to kind of be on the forefront of decarbonization, the technology, the maturity of the technology is there. It's just from this point forward, it's all of the things that we've always been doing with engine research. It's finding ways to improve efficiency and getting things to burn better, continuing to bring down the emissions, things like that.
Okay, so are there currently regulations around hydrogen vehicles? Are federal and state agencies allowing H2-ICE vehicles on the road? I know you said you can do it, but are there any regulations around that right now?
Yes, sort of. So that was a part of what brought this whole consortium and this demonstration program into being was this concern. So if you read the newspaper, you've probably seen headlines, multiple headlines about internal combustion engine bans. So a lot of governments and a lot of states within the United States have said going forward beyond, say, 2035 or 2040, we're going to ban all sales of internal combustion engines and only allow new vehicles to be registered as battery electric or these other zero emissions technologies. So there's this sort of regulatory limbo. You mentioned federal and you mentioned state. And so earlier this year, the EPA, which is the emissions regulator of the federal government, they came out with their Phase 3 greenhouse gas rules. And they have said that they will accept a pure hydrogen internal combustion engine vehicle as a zero greenhouse gas vehicle. It still has to meet all the emissions, so that they've set standards for other criteria pollutants like the nitrogen oxides and carbon monoxide and particulate. All of that is still in effect. They said as long as it meets those and is running on pure hydrogen, we'll call it a zero emissions vehicle. So that covers the majority of the country. But then separately, we have the states, particularly California, and their Air Resources Board has explicitly said they're going to ban engines, kind of starting to phase that in around 2035. And the timeline isn't exactly clear for heavy-duty vehicles and how that works out, but they have defined zero emissions vehicles explicitly as battery electric and fuel cell electric vehicles. And so that would exclude the sale of an internal combustion engine, even if it's running on hydrogen and making very low CO2. So part of our mission with this demonstration program is to get that message to CARB and EPA and other. There are about 14 states or so that have said whatever California does, we'll just follow that and adopt those same standards and regulations. And so our goal is to get that message out to say, here's another technology, here's another option, because we know this is going to be such a difficult challenge. We need everything that we can throw at it. And so why would we want to exclude a whole technology pathway from the decarbonization space when this gets us there with, maybe it's not perfectly zero emissions, but it's 99.9% of the way there.
Yeah, here's another option that can accomplish your goals.
Exactly.
So what do you envision for the future of hydrogen engines for heavy-duty vehicles and possibly beyond one day?
The near future will be very interesting because there's kind of a chicken and egg scenario that is developing right now, and it's similar to battery electric vehicles. If you've bought a battery electric vehicle, you may be frustrated by the number of chargers that are available and the infrastructure around using that vehicle. We're kind of spoiled in a sense that we've had a single technology for 100 years that has been the ideal solution. And so if you have a gasoline vehicle, you can go fill it up just about any corner in the country. You can find a gas station, and fuel is readily available, and it's easy and it's convenient. With electric vehicles, we're starting to feel some of that frustration just with the lack of infrastructure, and it will be very much the same with hydrogen. It's not like there is a whole existing network of hydrogen fueling stations. So if I were to buy a hydrogen truck today, there's nowhere to fuel it, and specifically in San Antonio, say, for instance. And so the technology adoption and the infrastructure are going to have to grow together. And that's one of the things that we're trying to do here at Southwest Research is to help smaller fleets kind of grow those things together. And so what we'd like to be able to do is to go to some small fleet operator like a delivery company. We'd like to be able to go to them and say, okay, what are your needs for your transportation? What kind of routes are your trucks taking? And ideally, if we can find an application where the trucks are going out, they're doing their work, and then they come back to the same spot every day, we can help them get set up with their own fueling station where they can refuel. They can start to get some experience around how do hydrogen trucks work, what's the maintenance and the cost of operating these vehicles, and kind of be self-contained at that point. And then eventually, as the adoption grows, then your infrastructure network grows as well. We'll start to see more stations. As we have more vehicles on the road, we'd see more fueling stations and vice versa. So that's kind of what I see as the near future, is kind of these smaller self-contained operations where they can get the fuel that they need to fuel just their trucks that are running on hydrogen. In the long term, there's the big question of, is this a bridge technology to 100% battery electric, or is this the long-term technology? And I'd say that still remains to be seen, but I do think that it is very feasible that in the long term, these technologies need to exist in parallel. There are a lot of applications that may be ideal for batteries, and there are a lot of applications that just will never work for battery electric without, barring some massive breakthrough technology in battery and power density and things like that. But I think in the end, we're going to need, I've said it before a few times, but I think we're going to need everything. If you look at our goals, so people are probably familiar with the Paris Accords, and many of the developed nations around the world have committed to be net zero CO2 by 2050. So that was a great thing. We all celebrated it. We came together and we're excited to do this. If you look at where we are on our pathway to achieving that net zero CO2, we've actually increased our CO2 emissions rather than decreased. And so we're going to need a lot more options. And the Department of Energy has kind of said the same thing, that it will take multiple solutions, multiple technologies, multiple strategies, all working in parallel to achieve, because it's a monumental task to fully decarbonize all of both transportation and industry and power generation and everything that we have become accustomed to. Will need both internal combustion engine technology as well as battery electric, as well as fuel cell and maybe others that will come along.
Yeah, 2050 is fast approaching, and hydrogen could be part of the solution there. So as you're talking and we're talking about refueling hydrogen vehicles, I'm wondering, where do you get hydrogen to do your research and development? Where do you order it from? How is it delivered to you? Yeah, how do you get it?
Yeah, so that is one thing that we have made a major investment here, just because of the number of hydrogen engines we're running for our own testing. We quickly came to the capacity. So there's essentially two ways that you can distribute hydrogen. It's either as high pressure gas, or you can supercool it and liquefy it. And similar to like a liquid nitrogen, or we do that with other fuels. We supercool them and liquefy them to make them more dense and easier to transport. Once we started running hydrogen engines here on our campus, we were originally receiving deliveries of these high pressure gases. And what we found was that very quickly we would run into the capacity of what you can carry on a trailer. And so we said we need to go to the liquid route. We put in the investment, a significant investment, to put in a liquid hydrogen tank. So that involves both cryogenic pumps and some insulated storage tanks and evaporators and a whole infrastructure to be able to handle the liquid hydrogen, but it significantly increased the capacity of what we could hold here and use on a regular basis. So those are kind of the two options right now. There are some other technologies where they're looking at kind of a chemical process where they can turn the hydrogen into some kind of a salt, and then you can dissolve the salt and it will release the hydrogen. So there are various options, but really the primary, I think, long term is going to be liquefying it, or eventually, if it gets to the point where there is massive use of hydrogen, then I envision something like a national pipeline network like we have for natural gas today.
Okay, so your H2-ICE engine is new. It's getting a lot of attention. And last month, your team showcased the consortium's H2-ICE demonstration vehicle at the 2024 Advanced Clean Transportation Expo in Las Vegas. So how was it received there? What were people saying about it?
There was a lot of excitement. In fact, to the point where a lot of people were confused about the purpose of the demo. They thought that we were selling a truck. And so we had people lining up saying, how soon can I buy one of these? Because there's enough... So people have got enough experience with battery electric Class 8 trucks now, and they're starting to get a little more experience with the fuel cell trucks. To the point where they're feeling the frustrations. Some of the limitations of batteries right now are the long charging times and the additional weight and reduced range of the vehicle. And so with all of those compromises, it makes it very difficult to economically run a business if it's based on transportation. So we had a lot of people that were very interested in H2-ICE from that aspect, just because it's more similar to their current experience with a diesel or a natural gas vehicle. So, yeah, there was a lot of excitement and a lot of encouragement for us to keep going and keep developing this technology and getting the message out.
So when people ask you, can I buy these now? What's the next step for them? Well,
so our consortium members, the way that our consortium model works is that any knowledge or intellectual property that is developed within the consortium becomes the property of the members. And so we have a lot of OEMs. We have truck manufacturers and engine manufacturers and suppliers that are all members of this consortia. They are welcome to go and take that technology and develop it. And so that's one pathway, is that we're looking for the large engine manufacturers to take this technology and get it to production, hopefully faster, because of the work that we've done to kind of lay the groundwork there. What we would like to do is get more of these demonstration. So we started with prototypes, and part of the problem with our vehicle now is that there's a lot of prototype parts. In order to drive that on the road and have all of the reliability and the durability and the safety aspects of that, each of the components would go through a pretty rigorous validation process. And because we have a lot of prototypes on our truck, they haven't been fully vetted through that process. And so that's kind of the next step, is for the consortium members to go and fully validate some of these to get them closer to a mature, full production product. And then at that point, we'll start to see more vehicles. We'd like to do maybe a next generation demonstration that is somewhere in between. So fewer prototype parts. That's always the goal, is to get to fewer and fewer prototype parts and more production parts. So we'd like to do maybe small fleet. We've done a single vehicle now. I think the next step would be, let's get a small fleet of maybe 3 or 4 trucks where we can, like I said before, kind of get a fueling station set up, let somebody actually go and operate these trucks and start to understand the challenges, the benefits, what do they like, what don't they like, what are there additional things that we just haven't seen because we haven't had enough time and experience with this vehicle.
At SwRI, our mission is to conduct research and develop technology to benefit humankind. So how does the new H2-ICE engine benefit humankind, and why should everyday people care about this advancement?
So kind of to bring it back to the beginning, it's all about decarbonization. And like I said, we are woefully behind in meeting our targets and making progress towards that net zero CO2. And so this gives us another technology. There are lots of models out there that show that we will reach our decarbonization goals much faster with a mixed technology rather than trying to force everybody into a single technology. So I think that's where the excitement is. That's where we're trying to benefit society is to bring as many options as possible. So I should say within our group here, we don't just do engines. We study fuel cells. We do a lot of work on batteries. And so within the Institute, we're not trying to promote any one technology. We're really trying to advance all of these things together because they're all going to be needed.
All right. So what motivates you to continue to develop and build this technology? Why are you excited about it?
I'm excited about this because I'm passionate about engines. Engines are pretty fascinating. It's why I got into engineering in the first place, was to develop engines. And I think the internal combustion engine is one of, if not the most, one of the most, I'd say, high impact technologies, or one of the technologies that has had the most benefit on the advancement of technology and quality of life and all of these things that we've come to enjoy. And so I'm excited that this breathes new life into the possibilities for engines going forward.
All right. So how can interested business owners learn more about the H2-ICE engine and explore how it could work for their fleet?
So we have a website for the consortium. If you go to H2-ICE.swri.org, you can get to our website. It's got kind of an overview of the engine and the program. It's also got some information about membership in the consortium for anybody who's interested.
H2-ICE.swri.org, and we will have that webpage on this episode webpage. Okay, so there are many applications for clean hydrogen, including power generation and manufacturing. And today we learned about the transportation applications. So you can learn more about SwRI hydrogen research and development on episode 42 of this podcast, Decarbonizing with Hydrogen. So Ryan, thank you for telling us about the H2-ICE Consortium and new demo vehicle, and for helping us understand the importance of hydrogen as a clean energy solution.
Yeah, thanks for having me.
And thank you to our listeners for learning along with us today. You can hear all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.